Welcome back after the shortest minute ever. We're continuing with more talks here at the Technical Forum. So be welcome, find a seat, people in the back, these are comfortable. We have drinks on the house, people online, welcome, we're thinking about you. Yeah, and by the way, if you do want to see these talks back, if you want to watch something back that you found interesting, all the talks will be published online and you can watch it back in the comfort of your own home or office. So that's good to know. All right, next talk, net zero paths with hydrogen storage in the UK and Germany. Important topic, and on stage here from SNC Lavelin will be Senior Mechanical Engineer Andreas Acht. Applause, please. Exactly.
Yeah, thanks a lot. Can you understand me? Very good. Yeah, thank you for the introduction. Yeah, important topic today, net zero path with hydrogen storage in UK and Germany. I do a little comparison of UK and Germany, how the approaches are and how the storage demands are and what are the differences. The reason why we compare these two countries is we have offices in these two countries and have to live with different scenarios that are at the moment valid. So we have to deal with them, and I will show you how they look like. First of all, I will introduce our company. So the company is called SNC Lavelin, and I work for the sub-company Atkins that was bought in 2017 from SNC. So we are now one company, and we are doing engineering for every kind of industry. So energy, any industrial stuff we do regarding minerals, metallurgy, transportation, and any infrastructure projects we do all around the world. And it's not going forward. Yeah, and we have combined some topics in the engineering. Oh, that's empty? Okay. In the engineering net zero group. So we deal with clean energy production, clean hydrogen production, distribution, storage, and utilization. And my focus today is on energy storage and on hydrogen storage. So when we talk about hydrogen storage, in this case, we mean large-scale energy storage for bridging over times of when we don't have renewable energies in the system enough. So we need to have some kind of replacement to balance the system, the supply and the demand side. And these big-scale energy storage we can realize in a subsurface storage. So in salt caverns, that is one solution. That is our expertise, where we support our clients with. So our clients are from the German business entity, mainly subsurface storage operator, where we support them in any kind of engineering they need to have. So we have geologists, geomechanics, well engineers, solution mining researchers, and PM stuff, and some mechanical engineers like I am. So when we come to the energy policy framework in UK, they have set some goals in their net zero emission law. So they want to reach net zero in 2050, and they want to reduce CO2 emission over the years to a certain extent, 78%, for example, they want to reach in 2035. And they have developed a 10-point plan for a green industrial revolution. That is shown on this slide. So what you can see here is the big topics. They are at the moment investing a lot of money in, 12 billion pounds is the budget for developing and supporting these topics. One major thing as well here is hydrogen and hydrogen storage. Also, what is different to the German policy, we will see, is they invest money in nuclear power. We don't do here in Germany. And they invest money in carbon capture, in storage and utilization. So that is something we don't do neither here in Germany. That is a big difference. Yeah, to reach these goals, they have really to speed up, to increase their power generation. It's not mentioned here with which type of power generation they will increase, but they have to do it in the next years, per year 9 to 12 gigawatts to add to the power generation to be able to have to reach this net zero goal in 2050. So that is a big challenge for the industry, and yeah, every country that has these goals is struggling at the moment to reach this build rate, like we are struggling in Germany as well at the moment. That is the hydrogen strategy they have developed for the next 10 years. I will not go into detail with this big, complicated picture. So they have a strategy, and besides production networks and distribution, also you can see here a storage current is important in the system, and they have also developed some numbers for what is the hydrogen storage demand they need to have in the future. So at the moment it's kind of zero, but with the increasing renewable energy system, and they need to balance the system as well, and they need some sort of energy storage and some capacity. So up to 2 terawatt hours in 2030, and up to 11 or 56, depending on the scenario and what you want to supply in 2050. So really big amounts of energy they need to store in the future. And that cannot be done in surface tanks. That's just too much energy. Don't know what I'm doing wrong. Good. So, energy policy framework in Germany is very similar. As I said, we don't have any nuclear in the future, and we will not have any carbon capture and storage. So we have only renewables, only fluctuating energy in the system. We have some supply from neighboring countries with some base load, but in the future, when we switch off our coal power plants in 2038, I think is the date at the moment where we want to switch off all the power plants, coal-based. We only rely on renewables, and we need to create, or we need to balance somehow the renewables, because they are fluctuating, of course. So net zero target in Germany is 2045, and we want to reduce the greenhouse gas emission in 2030 to down 65% less. This is the build-up rate of power generation for Germany, an estimation. It's done by a solar institute, ESE Fraunhofer. So that is clearly focused on solar power, new build, but you see the amount of new build, it's 25 gigawatts per year we need to have if we want to reach net zero only with renewable energies. So that is their estimation. In total, it's kind of 800 gigawatts we need to have installed until 2050 to reach this goal. And this is quite ambitious. I would say kind of impossible. We will not reach that. So we need to have something different to manage our energy system. So one part of the solution will be big storage facilities. This here is one scenario done by the DBI, that's an institute in Germany. They wrote a study about what is the hydrogen storage demand based on the current energy policy we have here in Germany, and they had different scenarios. This is just the outcome of one scenario. The others are quite similar, so we need energy storage facilities, hydrogen storage facilities within the next 3 decades, and quite a lot. So at the end, in this scenario, we need 50 terawatt hours. So that's a large amount for your information. So at the moment, the electricity consumption of Germany per year is 600 terawatt hours. So just for comparison. So this is how a salt cavern looks like. This is one type of energy storage that can be used as a really large-scale energy storage. So we have a big volume created by leaching the salt, and the volume can change, obviously. So you can create a big cavern in the salt and a small cavern, but this is just an exemplary cavern with a volume of 600,000 cubic meters. And the pressure you can operate this cavern, it's approximately 1,000 meters in depth. So the operating pressure is between 40 and 180 bar. And there you can store 180 gigawatt hours in hydrogen in one cavern. So for 1 terawatt hour, you would need approximately 5 caverns, a little bit more. So, and that is what we at the moment work on. So we have these assets everywhere in Europe for storing natural gas and oil and other products. At the moment, many storage operators want to switch or want to be ready for this storage potential for the storage demand in the future. So they are preparing themselves to change the storage medium to hydrogen. And that is what we support our clients with. Regarding the potential in Germany and in Europe, so what you see here on the right side, this is a map of all the subsurface storage facilities we have right now in Germany. And you can see there are more in the north. We have some porous formations in the south. They can be maybe reused for hydrogen, but they are not as good as salt caverns. So salt caverns are in the north, in the flat area where we have salt deposits. And many operators, as I said, are now changing their business from natural gas storage to hydrogen storage, or at least preparing it. Here you can see salt deposits that are suitable for hydrogen storage in Europe or in some European countries. You see here, northern Germany is completely filled with salt in the subsurface, but also in France, Spain, UK, and Romania, and the Netherlands, obviously. We have big geological suitable formations where these caverns can be created. There are already everywhere caverns which are used for natural gas storage at the moment in most cases. So, very exciting times at the moment. The whole industry, the whole storage industry is changing to renewables, and that's very exciting for us as engineers. And we need people. So if you're interested to join us, you can visit our site and apply for a job. We have a lot on our homepage, and you can have a look at Engineering Net Zero, and obviously we can discuss many details at our booth directly next to this public forum at B37. So, thank you. If you have questions, you're welcome to ask.
Thank you. And a warm applause for Andreas Acht, Senior Mechanical Engineer at SNC